Hello everyone, today we're going to be talking about limits. So previously we touched on the topic of limits, but we didn't call it that. I called it end behavior. So if we look at this first example, it says give the end behavior of each function. So here we see this function, and I want to know as x approaches infinity, f of x is approaching what value? So that's saying as we get closer and closer to infinity, what is the function approaching? So as we get closer and closer to infinity here, well, we see we have an arrow pointing down, so it's going to keep going down forever. So as x approaches infinity, f of x is approaching negative infinity. And forgive my handwriting for all of this, please. Then we have as x approaches negative infinity, f of x is approaching what? So as we get closer and closer to infinity, as we keep going up, what is f of x approaching? And as we see here, we have another arrow pointing up, so f of x is approaching positive infinity. So sorry, this first one's a negative, and then positive infinity. Let's look at the second problem. As x approaches infinity, f of x is approaching what value? So this time we see as x is approaching infinity, here it's going to the right, f of x is approaching this value here. F of x is approaching the value of 1. As x approaches negative infinity, f of x is approaching 1. So hopefully you guys remember this topic, this concept. And let's keep going. So the concept of a function approaching a certain value is called a limit. Earlier we were just calling it in behavior, but really it's just a limit. So given f of x, the function, the limit L of f of x as x approaches c can be written as there we go. Limit, so L-I, limit, don't worry, I have it written down here nicer so you can see, as x approaches some value c of f of x, ooh, looks terrible, I know guys, is equal to L. And if you can't read my chicken scratch, I completely understand. You'll see it further down nicer. Okay, so let's look at that first. Write the end behavior of each function as a limit. And as I said before, so the limit as x approaches c in this case is infinity. F of x is equal to, we're looking for L, the limit. And limit here is just abbreviated L-I-M, those 3 letters. So let's see, the limit as x approaches infinity. So as x is approaching positive infinity here. So as our x values are moving to the right forever, it's just going to keep going down forever. So that means it will be approaching negative infinity. Then we want to know the limit of f of x as x is approaching negative infinity. So here, as our x values are getting even smaller, f of x is still approaching negative infinity. Our arrow is going down. Let's look at our next one. So the limit of f of x as x is approaching infinity here. So as x approaches infinity, as our x values are getting larger, it's going to the right forever. But we can see it's approaching this y value. That's down 1, 2, 3, 4. Negative 4. And as x approaches negative infinity, so here as we go to the left for our x values as they're getting smaller, f of x is going up towards positive infinity. Now the limit in this fifth example, let's look at, of f of x as x is approaching infinity. Here it's going to keep going to the right forever, and it's approaching the value 0. Get closer and closer to 0. And then here, the limit as x is approaching negative infinity, while our f of x value is also approaching 0. So what if c is a certain value? So in all of our previous examples up here, our c value, the value that we're looking for it to approach, has been either positive infinity or negative infinity. But if c is a certain value, then the limit is the value in which x is approaching from either side of c. Okay, so let's see an example with a table. So example, estimate the limit of this function, x minus 8 over x squared plus 4, as x is approaching 2 by completing the table. And then we'll verify it by looking at a graph. So since we're verifying this with a graph, let's pull up our trusty graphing calculator. So for me, I'm going to use Desmos, so you guys can see too. You can't see all of it, so let me get out of it. Okay, now I think you can see. So to type in and get a table of values in Desmos, I can just click on table in the top right hand corner. I'm just going to make this x, and I'll change my y to reflect the function. So it's x minus 8 over x squared plus 4. Okay, what's empty lifts are not allowed. Okay, so let's see. So our first x value is 1.997. Okay, and we get negative 0.752. Then we have negative, 1.998. Okay, let's keep going. 1.999. Okay, so it's getting closer and closer to negative 0.75, it looks like. Well, now let's look on the right side of our table. So we have 2.001. Okay, so 2.001 is negative 0.749. Okay, and let's try 2.002. Okay, and 2.003, last one. Good, so we can see 2, which would be here in between 2.001 and 1.999. It looks like it's getting closer and closer to negative 0.75, or we could say negative 3/4. So let's write this down. The limit, we can conclude that the limit is negative 3/4. And please forgive me, I'm not going to write it down in this table. Here we can refer back to this table to help us. Okay, so that is our table. We're also going to verify this limit by looking at a graph. So let's go back to our graphing calculator. I'm just going to copy and paste it into our next slide. Okay, so here is our graph now. And we can see we're looking for the limit as x approaches 2. So if we go over 2, here we are. At this point, 2, you can see it is approaching negative 0.75. So that is our limit.